Hi viewers, welcome to LMS Solution. Today we are going to see about 5 megawatt grid connected PV system with the incremental conductance MPPT. So this is a simulation model for 5 megawatt grid connected PV system with the incremental conductance MPPT. And then here you can see that this is a PV array. Here you can see that the PV array having 11 model connected in series, and then you can see the 2.1325 into 10 power 3 parallel strings. Each panel, that means the single panel rating is to 13.15 watts. Voltage at maximum power point is 29 volt. The current at maximum power point is 7.35 amps. And open circuit voltage is 36.3 and the short circuit current is 7.84 amps. And it's going to be connected to the grid inverter via this boost converter, and this boost converter will be designed based upon the terminal voltage. Here you can see that 20 volt into 11, that means 29 into 11, 319 volt. At standard test condition, the terminal voltage will be 319 across this PV panel. And then here the DC link voltage, this is a DC link. This DC link going to be maintained at 800 volt. And then based upon power rating of the PV array, power rating of the PV array is 5 megawatt, and then you have to fix the ripple inductor percentage and the ripple capacitor voltage. That means ripple inductor current percentage and the ripple capacitor voltage percentage. Based upon this detail, we can design this LNC value. Already we have a lot of video about the designing of boost converter. You may check my YouTube channel for designing a boost converter, how we are going to calculate that LNC values. So just you go to check my YouTube channel. And then this boost converter, so this boost converter going to be controlled by means of MPPT algorithm. So MPPT nothing but maximum power point tracking algorithm. That maximum power point tracking algorithm is to extract the maximum power from the PV panel, because so this PV array depends upon two parameters like irradiation and temperature. When the irradiation temperature is going to be changed, that the PV and IV characteristics going to be changed. For different irradiation condition, you can see that it have the different PV characteristics, and then it have different peak powers with respect to that irradiation. This peak power should be extracted always in order to get the maximum power from the PV arrays. Then only you can utilize the maximum power of the PV. For that, we need a MPPT algorithm. Here we are using the incremental conductance MPPT. So the incremental conductance MPPT receiving two inputs. One is VPV and IPV, and finally this will be provided duty cycle. Inside the incremental conductance MPPT, we have to fix the parameter like initial duty cycle, maximum duty cycle, minimum duty cycle, and then you have to fix the increment, decrement, change in duty cycle. And also you have to fix the 4 parameter like the previous voltage, power, duty cycle and the current. And then you have to provide the initial value for the previous voltage, power, current and duty cycle. And then here you have to calculate power of the PV panel, the change in voltage, change in power, change in current. So next you have to apply the incremental conductance MPPT conditions. First you have to check the change in voltage, whether it is equal to 0 or not. Next you have to, if suppose it is equal to 0, next you have to check the change in current equal to 0. If both condition equal to 0, dV equal to 0, dA equal to 0, means already the PV will be operated to maximum power point condition. That means you can draw, this is IV PV and this is PV characteristics. This is IV characteristics, this is PV characteristics. Already when this condition true, already this will be operated to maximum power point condition. If suppose the dA is greater than 0, means we need to decrement the voltage of the boost converter. So if you decrement the voltage, means in this point it will be operated in this region, so we need to increment the voltage. Further we need to decrement the duty cycle. If suppose a dA is less than 0, means it will be operated in this region, so we need to increment the duty cycle in order to move from this side to this side. This is a condition when this dA is greater than 0 and dA is less than 0. Next incremental conductance MPPT that means condition is dA by dV equal to minus I by V. This is the incremental conductance. So you have to equate incremental conductance, which is equal to minus I by V. If both are equal, it will be operate this point, maximum power point condition only. No need to change the duty cycle. If dI by dV is greater than minus I by V, that means it will be operate in this point. So we need to determine the duty cycle by duty cycle to increase the voltage. Otherwise, you have to that when dI by dV is less than minus I by V, it will be operate in this region. We need to increment the duty cycle to reduce the PV voltage in order to bring back to the maximum power point. So this is a working of that incremental conductance MPPT. This is a code for that. Finally, we have that duty cycle here. The duty cycle going to be processed via PWM generator. PWM generator nothing but a pulse width modulation. Just you to compare duty cycle with a triangular wave or a sawtooth waveform, it will be generate the pulse. That pulse going to be control this IGBT in order to extract the maximum power from the PV as well as maintain the voltage of the PV at the maximum power point condition. And next you have to go with the inverter, grid inverter and filter design. This filter design going to be designed based upon that the ripple inductor current and the power rating of the PV and then voltage of this grid. Here the voltage rating is 400 volt and the frequency is 50 Hz. We are consider. You have to design this filter accordingly. And then here you need to control this inverter. Inverter going to be controlled by means of two concepts only. That means we are going to combine both voltage control and current control. The voltage control is to for maintaining the DC bus voltage at 800 volt. For that you need to measure the DC voltage and you're going to be compared with the reference voltage. And then it's going to be converted into per unit and then it's going to be processed via PI controller. This PI controller nothing but voltage controller. The input will be error voltage and the output will be the current reference in the form of DQ. Here from this PA controller, this voltage controller, it will be generate ID reference. Here we are going to control only real power. The another input IQ reference will be left blank. Here we are considering 0. And that's why we are not connecting anything here. And then we need to measure the grid current. Here you have to measure the grid current and then grid current going to be converted into per unit and then it should be converted into DQ0 form. It is in ABC form. So we have to control the system in DQ form. We need to convert. So here we are applying the power transformation. So in order to apply this power transformation, we need omega t. Omega t nothing but a phase angle with respect to time. The phase angle with respect to time will be taken from the PLR. Input for the PLR will be grid voltage. The output will be the phase angle with respect to time. So that will be used for converting that ABC to DQ0 by using power transformation. After that, we are going to control ID and IQ. So we have to take only ID and IQ value and then we will be compared with the ID IQ reference. And here you have to process via current controller. This will be act as a current controller. Input will be error current and the output will be controlled voltage. Next, the controlled voltage will be converted into ABC form by using inverse power transformation. And then here we have the modulating signal in the form of three-phase waveform, ABC form, that going to be processed via the PWM generator, sinusoidal PWM generator. So this will be generated 6 pulse. The 6 pulse will be going to control this inverter in order to inject the power from the PV to grid. Whatever power available in the PV, that will be sent to the grid. Here you can measuring the PV voltage, current and the power. And here we are measuring the grid voltage, current and the inverter voltage and current. Here you are measuring the grid power and inverter power. And then this one used for measuring the duty cycle. And then this one used for measuring the modulating signal. And then this is the DC link voltage. Now I am going to simulate the model. We have to check the result of the system. Now the system operated at 1000 watts per meter square. You have to wait for some time because it is initializing the simulation. You have to wait for some time for initialization. After that it will be start executing. Our simulation start executing. And then here you can see that this PV voltage is maintained. This is come nearer to the maximum power point voltage around 399 volt, 319 volt, and then current will be around 15,000 amps. Here you can see that we are generating maximum power of 5 megawatt. This is a duty cycle variation. Okay, of this from that incremental conductance MPPT. And then this is grid voltage and then grid current. This is a inverter voltage. This is inverter current. Here you can see that we are sending power from the PV is around 5 megawatt and then grid also is receiving power around 4.8 8 megawatt. So this is a control signal from that inverse spark transformation. That means from that voltage and current control of the inverter. And then here you see that the DC link voltage is maintained at 800 volt. Now I am going to change the timing, and also I am going to change the irradiation to 500. Now we are going to check the result of change in irradiation condition. Now we can see that because of change in irradiation condition, the current of PV is reducing, and then voltage is maintained around that 300 volt only. Current will be around 7.5 kilo ohms, and then you can see that the power is comes around to 2.5 megawatt. This is a duty cycle. Now we are that means incremental conductance is generating. Here you can see this is the grid voltage, and grid current is reduced, and inverter current also reduced. So this is the inverter voltage, and also you can see the variation of modulating signal, and then changes in the grid power and inverter power. Here you can see that the DC link voltage maintained around 800 volt only. So this is the working of 5 megawatt grid connected PV system with the incremental conductance MPPT. Thank you for watching our videos. Kindly subscribe our channel and also click bell icon for notification about upcoming videos. Thank you so much. Bye bye.